All right, so welcome to this tutorial. And in this video, we're just gonna answer Math 11, Math 2100, that's tutorial sheet 7. And we have the following problems. So question 1 says, let R be the position vector of a moving particle at time t, find the velocity and the acceleration. So we've been given that we have these vectors, R. So R is a vector which we're dealing with. And the first one has A, that is A sine t, that's ith component, then plus A cos t for the j, then plus 2 sine 2t, that's the kth component. So now you're telling us to find the velocity and acceleration. So in order to find this velocity and acceleration, what we just ought to do is to differentiate. So for the velocity, we have to differentiate once, then again, for the acceleration, we have to differentiate that twice. So, meaning to get the velocity, we are just saying that our velocity, so velocity at time t of this particle is just r prime of t. And this here is going to be, so we have sine 80, so we differentiate this here. Sine, we get cosine, so we just have this will be a cos, this is a cos t. Then the other one, this is cos t, so when we differentiate that, we get negative. So you have to differentiate each and every component, so you get negative sine. This is a negative sine t, that's for the jth component. Then this one, we have 2 sine 2t, so differentiate the sine 2t, this just gives me cosine, so I have plus cos 2t, but this is now chain rule, so I differentiate this 2t, which gives me 2, then the 2 multiplies with this 2 in front, and I get a 4. Then this here is going to be for the case like that. So now this here is the velocity of what? Of this particle. Right, so next we get the acceleration of this particle. So the acceleration, which we say a of t, is going to be, so we differentiate this again, so we get r, this will be double prime at t, this is going to be, so now cos, I differentiate that there, I'll get negative sine, this will be negative sine t, the ith, then this here, sine, differentiate that, I get cos, so this will be negative a cos t, that's for the jth. Then I differentiate this last part, that will be negative sine, negative sine 2t. Then I differentiate the 2t, that gives me 2, then the 2 I multiply by the 4, that gives me 8. So I have this here. Right, so this is going to be the, yeah, this is going to be the acceleration. So this is going to be the acceleration of this particle, right? So let's do the next one. So next one, we do the same. So to get the velocity of this particle at the time t, we say vt, then we say we differentiate this once, like that. Then we see what we're gonna get. So, so for this one, we have, when we differentiate this part here, this gives us 2 to the first part, that is for the ith component, that gives me 2 t minus the 1, this becomes 0 because that's a constant, so you get I. Then the next part there, plus, then that is 3t squared, so 3t squared. Then this here, that will be plus, that is 6t, like that. So this is for the jth. Then I have the last part will be, I differentiate 5t, I just get 5. That's for the case. So this here is going to be, or this here is our velocity. Next, we look at the acceleration. which is just going to be double prime of the r evaluated at t, or of that particle at time t. Then we get first that to give us 2. So we differentiate this, we just remain with 2. Then we differentiate that there, we will have, that'll be plus, that is 6t. Then there we have plus 6. Then that's for the jth. Then here we just have 5, which is a constant. So you just have plus 0 there. So this here is going to be our acceleration. Okay. Right. So next, question 2 says for the motion in question 1, find where the particle, so saying find where the particle is when the velocity vector is parallel to the xy plane, and they're telling us also to find the speed at that point. So meaning from what we found in question A, and then what we're interested in from question A is the velocity vector. We're saying we want to find where that particle, when the velocity vector is what is parallel to the xy plane. So it is parallel to the xy plane. That is when the kth component is equal to 0. So for our vector which we had, so let me write our velocity vector again. So our velocity vector for part A was this, that is A cos ti. Then you have A sine, that is tj, then plus 4 cos 2t, that's for the kth component. So now we're saying that our this vector is going to be parallel to the xy plane if the kth component is what is 0. So meaning that it only deals on the xy plane and has no shift in space. So that there is just going to be equal to 0. So we equate this kth part to 0. So we are going to have that 4. So we say 4 cos 2t, then we equate it to 0. So this implies, so when I divide by 4, I just remain with cos 2t equal to 0. Then you see that from here, taking my cos the other side, I have that 2t cos inverse of 0 there. So now this cos inverse of 0, generally, you see that I'm going to be having, that is from 90. So cos I know that cos 0 at when it passes through 90. I mean cos inverse. I mean cos 90. Cos 90 is 0. So cos 90 is 0, meaning the cos inverse of 0 is going to be what? 90, which is just pi over 2. So pi, here we say pi over what? Pi over 2. But then we know that when we continue to add, that is pi to this here, we'll still be getting uh, 0. So each case we add pi. So we say n pi, that is. So I can add pi, I can add 2 pi, add just like that. It continues to give me what? To give me 0 as well. Since they've not given us a limit in which, or the interval in which our t is valid, or in which to work with, meaning generally it's going to look like this. But then to get t itself, since this is 2t, multiplying by the reciprocal, which is just like 1 over 2, I'm going to have that t is going to be pi over 4 here. So I have pi over 4, then I have plus n pi over what? Over 2. So of course, n being just any integer there. So this is what I'm going to what? This is what I'm going to get. So since it's not been specified exactly what we are working with here, or in what interval we're working with, so generally you're going to have this here. So what does that mean for us? So that means that this first part, which is telling us to find where the particle is, so the particle is going to be, so generally it's going to be A cos, so there it's cos t, then you have A sine t, then of course you're saying this is 0 because that's when it's parallel. So now at values of what? Values of t. So values of t, which is here, saying values of what? Values of t, going like that. So presuming that our n is 0, meaning I have pi over 4, then pi over 4, replacing it in there, meaning that will be the point where I will be at, that if I'm starting there. Then I continue like that. It will depend on the what, on this t. So our t is like this. So the point where we'll be will depend on what, on the t. But generally, this is how the point, this point of the particle. So find the particle where the particle is. So this is where the particle will be, like this, at a given what, at a given value of t. And we've seen that this is how we have found our t to be. So meaning at any value where, of course, n being an integer, at any point where you put that there, you're going to have what, different points or where it's going to be. Yeah, but if they had specified a certain interval, would have restricted that. Or if they had given us to say we are just dealing with the first part of it, meaning we would have just what, replaced. So if you look at the first part, if we were just dealing with the first part, so, or with the first value, meaning we're just looking at pi over 2 here, that is when, say, cos inverse of 0 would be looking at pi over 2, then we have the 2t to be equal to pi over 2. So meaning the t here going the other side, meaning your t will just be pi over what, pi over 4. That's if it was specified, but it's not specified. So we take it generally like that. Now, they are also telling us here to find the magnitude, or I mean to find the speed at what? At that point. So we have that there, and they're telling us to find the speed at that point. So how we find the speed is just to find the magnitude of what? Of our what is our particle at that point. So the particle at that point, we just ought to find the magnitude. So what we do is we're just saying find the magnitude like that, which is just going to be square root. Then I put my a, so a cos, t squared. Then I have plus negative a sine t squared plus my 0 here squared. So since we're saying that it's parallel to the xy plane, so the kth component there is going to be what? To be 0. Then I'll have that. Here I'll have a squared. So you see I have a squared and a squared from there. Then I'll have cos squared t plus sine squared t, like that. The 0 when you square it still becomes 0. So this is what I'll get. Then from here, what is this going to be? So now, you notice that this here is the identity which gives us 1. So meaning I just have root a squared like that. So the root a squared, I can redefine this by how the modulus is defined, meaning this is just the modulus of what? Of a. This is equal to that. That is equal to the modulus of what? Of a. So this is, so whenever the velocity lies in the xy plane, meaning the speed is going to be what? To be this. Whenever it lies in the xy plane, that is going to be what? To be our speed. And according to the what? To the time t which we found, that is going to be our speed. So what we are saying is, for example, if we took our t to be pi over what? Pi over 4, we took our t to be pi over 4, then we would have v to be, so we would have our v to be, okay, so here remember you have a cos t, so where there's t you replace pi over 4, where there's t you replace pi over 4, and you see that pi over 4, that's just 45 degrees, and you just have cos 45 is just 1 over 2, like that, 1 over 2. So meaning here you just have, okay, let me write it here. So if I say a cos pi over 4, then here negative a also sine pi over 4. then of course I have the 0 there. But when I place this here, I'm just going to have a over what, root 2, then negative a over root 2, then I have what, 0 there. So this here is going to be when t is what is pi. That's where my particle is going to what is going to be. So yes, so that's how you find that. And then my speed of the particle, as I said, is going to be this one here. Just find the magnitude of that vector there. Of course, when the component is what is 0, because we're talking it being parallel to the what, to the xy plane. Okay, now for part B, we cannot proceed to find this. The reason is when you look at the kth component, of my vector is just a constant, which is 5. So 5, I cannot equate it to anything. So meaning that this here can never be non-zero, because we know 5 is not equal. This 5 is not equal to what? To 0. So meaning it can never be parallel to the what? To the xy plane. So for this one, just leave it like that. All right.